All right, we are going to be doing two different things in this video. One of those things is going to be converting between exponential form and log form. And then, like I said, we're going to be learning about how these are inverses of each other. So we already discussed that the graphs are inverses, and we were able to see that as x and y values kind of trade. And now we're going to look at it algebraically, so not using graphs. All right, so if we start with an exponential function, y equals b to the x power, then for me to convert that into log form, convert it into its inverse, I have two different ways I can do that, and I'm going to show you both ways, and I'm going to let you choose whichever way you prefer. So the way that I learned to do this when I was in high school, my teacher, I think, called it the Tootsie Roll method. But what you do is you start with the base. So you would say, I'm converting it into log form, so it would be log base b. And then you Tootsie Roll, which means you just go around in a circle. So log base b of y equals x. So that's one way for you to do the conversion. The other way, and this is something I learned as a teacher, and to be honest, I like this better. So starting off with the same thing. The other way to do it is to think of the inverse operation. So we're learning that exponential functions and log functions are inverses of each other. So if I want to undo the base of this so I can get to the exponent, then I need to log each side. And for me to log each side, the base has to match the side that I'm logging. So what I'm going to do is I'm going to say if this is a log, or if this is a base b to an exponent of x, then to undo that, I need to log base b that side. You can't really see that. And I need to log base b the left side. So what that leaves me with is I have log base b of y equals log base b of b to the x, and log base b of b cancels because those are inverses of each other. So it's kind of like saying I divided by 5 and I multiplied by 5, those cancel. Or I added 2 and I subtracted 2, those cancel. So if I log base b something where there's a base to an exponent, then those would cancel, and I end up with the exact same thing. So the reason that I like that is because a lot of students, if they do this Tootsie Roll method, they will forget that there's inverses, that these are inverses of each other. And if you think about logging both sides, then you remember that. The same is true for the reverse. So if I start with a log, y equals log base b of x, and I want to undo that log and convert this into exponential form, I can do the Tootsie Roll method again. So I start with the base. So base b to the y equals x, right? Or I can use inverses to do the same thing. So if I have y equals log base b of x, then I can take each side and write it as an exponent, a base to an exponent, and it's called exponentiating each side. So this one's kind of fun because it's got a weird word, but I'll put base of b right here, base of b right there. So what I have written now is I have b to the y power equals b to the log base b of x power. And the b and the log base b are opposites of each other. They're inverses, and so they cancel. And then that would just leave me with b to the y equals x. So two different ways of doing it. It just depends on what way makes you feel more comfortable, okay? So we're going to go ahead and do some examples that don't have all variables in them. We're going to look at a problem like if I want to take 81 and say 81 is 3 to the 4th, then how could I rewrite that as a logarithm? So if you were doing the Tootsie Roll method, you would say, okay, here's my base. So you would say log base 3 of 81 equals 4. If we want to do a similar problem, but we want to use the inverse method instead, I could say, let me think of something. It's hard to think on the fly. I could say 81 equals 9 to the second power. And I could say, all right, I want to get rid of a base of 9. And so I have to log base 9 the left side and log base 9 the right side. And then this log base 9 will cancel with that base of 9. And my answer would be log base 9 of 81 equals 2. So either of those methods work. I think they're about the same level of difficulty when you're not showing all your work for everything. So you choose the way that you prefer, and then we'll try to stick with that. For the next example, we're going to start with something that's in log form, and we're going to convert it into exponential form. All right, so here we have log base 2 of 32 equals 5. So to convert it into exponential form, we're going to start with the base. So I'm going to say 2, and I'll go ahead and Tootsie roll. 2 to the 5th equals 32. So when I do that Tootsie roll method, you'll notice I always start with the base. And then to know what I should do next, I just go to the opposite side of the equal sign. So these are kind of written backwards from where I wrote these example problems. Here's where I wrote it. So I circled the base and then I went to the left to do my circle. Here, since it's backwards, I circled the base and then I went to the right. So whichever way you do it is totally fine, but I'm starting with the base and then going to the opposite side. So that's one option. I could do that, or let's say I did log base 5 of 25 equals 2. Then what I could do is exponentiate each side. So I could say the base of the log is 5, so the base of the exponent is 5. So I have 5 to the log 5 of 25, 5 to the second. So the 5 and the log 5 would cancel, and I would end up getting that 25 equals 5 to the second power. All right, so both of those methods work just fine. Okay, so let's go ahead and look at finding inverses of equations. All right, so we could add another heading in here. I'm going to go ahead and get a fresh sheet of paper. So we're going to find inverses of exponential and log functions this time. So we'll say we have y equals -2 times 3 to the x plus 1 minus 4. So if you guys recall, when we find inverses, all we have to do is trade the x and the y and then solve for y. So that's what I'm going to do first. I'm going to say x equals -2, times 3 to the y plus 1 minus 4. And then I'm going to start moving stuff to the other side. So first, I'm going to look for things that I could add or subtract to the other side. So I can go ahead and add the 4 over. Next, I'm going to look for things that I can multiply or divide to the other side. I can go ahead and divide both sides by -2. So x plus 4 divided by -2. And then Next, I deal with my exponents, and so here I'm going to deal with getting rid of my base of 3 so that my exponent is alone, because that's what I need, is I need to be able to get to the y and the exponent. So before I do that, I'm going to go ahead and take care of this negative right here. So we know that typically they would not leave the negative on the bottom of the fraction. Typically they would move it to the top. And then we could go ahead, you could leave it out, you could distribute it. I'm going to go ahead and distribute it. Okay, so at this point, you can Tootsie roll to get this into log form, because we know that logs are the opposite form of exponents, or we can do log base 3 on each side to undo that operation. All right, so what I'm going to go ahead and do is I'm going to log base 3 each side. So log base 3, log base 3, and the log base 3 on the right side cancels with that 3. So on the left side, I have log base 3 of negative x minus 4 over 2 equals y plus 1. And now all I have to do is subtract the 1 to the other side. And since my answer is an inverse function, I'm going to go ahead and use that inverse notation. Okay, let's go ahead and do another example. Y equals 1/2 log base 2 of x plus 3 minus 1. And so first thing, when we're doing inverses, we trade our x and our y. And then I work my way through just order of operations backwards to try to get the y alone. So my first step is to see if there's anything that I could add or subtract to the other side. Sorry, it's sunny. So I can go ahead and add this 1 to the other side. Next, I'll see if there's anything that I can multiply or divide to move it to the other side. You can divide by a 1/2, but it's a little bit easier to just multiply the 2 over to the other side. And so I'll say that we have 2 times x plus 1. And so that's really 2x plus 2. And then at this point, we want to be able to get inside those parentheses. And so to do that, we need to get rid of the log. And this is where the E comes in. Step 3 of your order of operations is exponents. And we don't have an exponent right now, but what we're going to do is we're going to exponentiate each side, and that's going to write the problem as an exponent, but it's going to get rid of that log. And so the log has a base of 2, so I'm going to do base of 2 on each side. So 2 to the log base 2, those are going to cancel. And so I have 2 to the 2x plus 2 equals y plus 3. So I did the inverse operation, and the equation that used to be written as a log is now written as an exponential function. And then I can go ahead and just subtract the 3 over to the other side. And since that was an inverse, I can go ahead and put that -1 for that inverse notation. And there is my function.